Hello everyone, my name is Sherry Yanjurus and I am from SMK St. John Beaufort, Sabah, Malaysia. This project is called CHEMCODES, an AI-assisted learning simulation developed to help secondary school students to understand, to write, and balance chemical equations in chemistry. Our journey began with only one classroom challenge, but it has grown into a wider culture of innovation among teachers and students. Chemical equations are often described as the language of chemistry. When students cannot write and balance equation correctly, the difficulty continues into chemical reactions, stoichiometry, mole calculations, and other advanced topics. Therefore, addressing these foundational skills is important not only for examination performance, but also for building long-term conceptual understanding and confidence in chemistry. CHEMCODES was developed with 5 main objectives. First, to design an AI-assisted simulation for writing and balancing chemical equations. Second, to provide interactive visualization and step-by-step guidance. Third, to evaluate its potential to improve understanding, accuracy, and engagement. And the project also aims to support teachers and promote digital literacy, computational thinking, and responsible using of AI intelligence. CHEMCODES is an interactive learning ecosystem that transforms abstract chemical equations into a visual and meaningful learning experience. It was developed using Canvas in Gemini and include particle level visualization, immediate feedback, guided balancing, and unlimited practice. Instead of simply giving students an answer, CHEMCODES helps students understand why an equation is balanced and how the conservation of atom is represented. The learning process follows 6 clear steps. Students first identify the reactants and products. They then write the chemical equation using the correct formulas. Next, they balance the equation step by step. CHEMCODES visualizes the particles, compare the number of atoms on both sides, and provides immediate feedback. Students can repeat the activity until they achieve mastery and confidence. CHEMCODES was developed through ADDI framework. During the analysis phase, students' learning difficulties were identified through classroom observations, literature, and teacher feedback. The simulation was then designed according to curriculum objectives. It was developed using Canvas in Gemini, implemented with Form 4 students, and continuously refined through feedback, observation, and learning performance evidences. With CHEMCODES, students move from passive learning to active exploration. They can see how atoms are arranged, receive feedback immediately, and learn at their own pace. Visualization helps them connect chemical symbols with particle behavior. This makes the learning process more engaging, reduces fear of making mistakes, and encourages students to learn and to keep on trying. CHEMCODES is expected to support stronger conceptual understanding, greater balancing accuracy, and increased student confidence. It's a step-by-step structure that allows students to practice more effectively, while teachers can identify misconceptions and provide targeted supports. This platform is also designed to be flexible, scalable, and accessible across different devices, making it suitable for classroom, home, and blended learning. CHEMCODES directly supports SDG number 4, quality education, by making chemistry learning more accessible, engaging, and student-centered. It also supports SDG 9 through educational innovation and the use of digital infrastructure. Collaboration among teachers, schools, and higher education institutions reflects SDG 17, partnership for the goals. Together, these goals position CHEMCODES as an innovation with educational and sustainable values. CHEMCODES respond to a real local classroom challenge: students' difficulty in writing, visualizing, and balancing chemical equations. This project is also supported by wider research showing that interactive simulations can improve engagement, conceptual understanding, and problem solving in science education. Therefore, CHEMCODES connect local educational needs with global developments in digital and AI-assisted learning. CHEMCODES is designed to grow beyond one classroom. As a web-based and device-friendly learning resource, it can be shared across classes, schools, and professional learning communities. New topics, simulation, and language options may also be added. Its wider potential includes improving STEM literacy, strengthening teacher innovation, reducing dependence on printed materials, and building partnerships between schools and university. In conclusion, CHEMCODES addresses a fundamental chemistry learning challenge through visualization, interaction, and guided practice. It helps students see what cannot be seen in traditional textbooks, understand the conservation of atoms, and practice without fear of failure. CHEMCODES turns confusion into clarity, practice into confidence, and abstract equations into meaningful understanding. CHEMCODES represents our commitment to quality education, meaningful innovation, and a more sustainable future for learning. From SMK St. John Beaufort, Sabah, Malaysia, thank you for your time and consideration. Together, we make chemistry visible, simplifying equations, strengthening understanding, and shaping the future of chemistry education. Thank you.
Thank you, Puan Sherry. Well, before I've been introduced to Canvas and Gemini, I had no idea that I could develop my own simulations. And Puan Sherry continuously sharing her experience developing simulations using Gemini Canvas about chemistry simulations, and always encourage us, the teachers, to explore and how to integrate AI in our teaching. Through her guidance, mentoring, and encouragement, I had learned how to use Canvas in Gemini to develop my own simulation, which called CycleSim. It is a simulation of menstrual cycles. It is a biological-based educational simulations. With her support, I participated Teachers Makers Challenge in Asian Maker Face 2026 at University Malaya, where my project received a silver medal award. What inspired me the most is her belief that innovation should not stop with one teacher. She actively empowers colleagues and students to become creators, innovators, and lifelong learners. Her leadership has transformed the culture of our department and also encouraged many of us to embrace AI and educational innovations in education.